Hello there, this is KP, the Math G, and I'm here to just make a little brief lesson. I want to make a two-part lesson. One is on the average velocity, and the other is going to be on instantaneous velocity, which is really the limit of the average velocity. Let's look at a position function. It says the position function of a point P moving along a line is s at t is equal to 2t squared minus 5t plus 3. Find the average velocity on the closed interval 2 to 2.5. Well, here's our average velocity equation or formula. It is s at a plus h plus s at a plus h. So really all you're doing here is saying that this is s is actually here. Okay, this is it here. So here we go. Let's see, the average velocity is equal to s at the larger number 2.5, okay, minus s at the smaller interval rather, at 2, and then h is just equal to 2.5 minus 2. It's important that you understand that h is equal to 2.5 minus 2, which is really 0.5. Okay, so that is what we're talking about here. Okay, let's go ahead and plug these in. We'll use my calculator for this. Okay, so let's see, this is now equal to, now remember, no limit because we're looking for the average velocity. Okay, no limits here. Just plug it in like this. Okay, so 2 times 2.5 squared minus 5 times 2.5 minus 2. Okay, I'm sorry, that is not minus 2, that is plus 3. Now then, minus, and I like to do this now. Let's see what we've got here. Okay, it's at 2 now. So from here, you're going to put the 2 right here, s at 2. So 2 squared minus 5 times 2 plus 3. Okay, and then all over 0.5. Okay, that's pretty much it. We got the numbers in there, and I'm not sure now. I've been away from it for a little while, but if you're a teacher, maybe you can help me with this. If they plug the numbers in, do they have enough? Or do they have to find the average velocity? Do they have to find everything? Okay. If this is a multiple choice question, obviously you have to come on and get the answer. But if it is kind of like a open response question, then you can probably just plug the numbers in and be done. But anyway, let's go ahead and do it. I want to find the answer to this. Okay, this is 2 times 2.5 squared minus 5 times 2.5 plus 3 minus, as parentheses, 2 times 2 squared, which I believe to be 8, minus, 5 times 2 is 10, we know that, and then plus 3, close that parentheses. I'm going to hit enter. I got something way bigger than I had when I first figured this out by hand, but it's okay. Alright, I'm going to refigure it again. For whatever reason, I did something incorrect as I was doing this problem. Okay. I got 27. I'm going to put that down for the time being, but I want to double check 27 over 0.5, which that actually doubles it if this is correct. So 27 divided by 0.5 is the same as multiplying by 2, and that is going to be 54. Let me double check now. 2 parentheses 2.5 squared. Okay, minus 5 times, let's do it this way, 2.5, bear with me just a little bit, I like double checking anyway, plus 3, okay, and then of course the minus here, so minus, parentheses, 2 squared, okay, minus 10 plus 3. Enter. Well, the second time I get 2, and that's what I got the first time. Okay, I don't know why I got 27 the first time, and this is what I got the first when I figured it out by hand. Okay, this is 4, and let me double check again. Since we got 2 different answers, we might as well do it one more time. So here we go. 2 squared minus 5 plus 3. I'm going to go ahead and figure that out. This top portion is saying this part right here is 3. Okay, let's see what we get here. 2 squared is 4. 4 times 2 is 8. 8 minus 10 is negative 2, and negative 2 plus 3 is 1. Indeed it is. So, alright, so that's what I got the first time. Okay, where I got 27 from, go figure. I probably did something incorrectly from the start, and okay, my calculator will not allow me to go up on that or to scroll up and see where I might have made an error. But after doing this 2 times and getting 4 in the numerator, I'm convinced that the answer is 4. I did it by hand and got 4, and as it should be. Okay, actually the numerator was 2 divided by 0.5 is 4. Okay, alright, so average velocity, if we're looking at average velocity, this would, in this case, if we're looking at, don't see any units here per se, but if this is in, say, feet and seconds, if time is in seconds and the distance is in feet, this would be 4 feet per second. The reason we don't have units here is that we did not place any units on this from the start. So this is the idea behind finding the average velocity. I may go ahead and continue. Now let's see where we get. I may just go ahead and continue. So let's do that. I want to go to another problem actually. Okay. I have not finished writing the problem down, so let me do that now. Okay. And I actually worked these out, so So bear with me as we do this. Now this is going to be instantaneous velocity as opposed to the average velocity. Okay, so 320 feet, okay, above the ground. Above the ground. This other problem finished out so quickly, I decided to go ahead with this one. The distance let's see what we got here. That's a T, and that's always, anytime you see S like this, that will usually be distance anyway. Okay, in feet. From the ground. Is a T is equal to negative 16 T squared plus 320. Okay, that's the distance equation. Okay, there is a rule later on that if you take the derivative of the distance, you're going to get velocity. And if you take the derivative of the velocity, you get what you call acceleration. So we have first and second derivatives, which we're going to look at a little bit later on. But this is instantaneous velocity, what we're looking at this point right here. So we want to find the instantaneous velocity. I'm just going to say velocity. Alright, in feet per second at, and for right now, I just want to say a seconds. Any A. Alright. And then maybe we'll find some more specific one, say at 2 seconds or whatever. Alright, so here's what we did last time. Remember that the average velocity is S at A plus H minus S at A all over H. But the instantaneous is going to be as H approaches 0. Now we have what we call the instantaneous velocity. Okay, and so that's what we're looking at this point. Well, let's do it. It's going to be long, and that's what we're going to do. We're just going to do A, and we're probably going to stop at that, and then we'll come back in another lesson and review this again, and then find it at, say, at 2 seconds or something like that. Okay, so let's see. Let's do our limit as H approaches 0. I hope I do well on this one here. Alright, so here we go. In place of T, we're going, in this T here, we're going to put A plus H. So here we go. This is negative 16 A plus H squared plus 320, okay, minus, I like to do this again. Okay, that's S at A. All I'm doing is putting A in its place, so negative 16 A squared plus 320. Okay, and I could have just used parentheses just as easily over H. You have to flip the board back over. Obviously I will. Alright, so we have to square A plus H, and I did that in a previous video before. going to go ahead and go through it. Negative 16, you're squaring the first term, a squared, okay? And then you're going to multiply these two together and just simply double it. So 2AH, and then you're going to square the last term, plus h squared, and then plus 320. And then you're going to distribute the negative sign, so plus 16a squared minus 320 all over h. Okay. Well, let's see if we can squeeze this in one more time. So let's see if we can put it down here before I have to flip the board. Maybe I can get away with this. Let's put it down here. Squeeze it in. Alright, so the limit as h approaches 0. Alright, so this is going to be negative 16a squared, negative 32 ah minus 16 h squared plus 320. Ooh, I'm running out of room fast. Okay, luckily we only have two more terms here. Excuse me while I move the board. Hopefully I won't move it too far out of position. Okay, so plus 16a squared minus, squeeze it in, 320 all over h. The reason I put this here is so that we could see that there's something that cancels out, okay, so negative 16a squared plus 16a squared. This should be a plus right here. Okay. Nope, that's minus. My bad. Okay. Plus 320 and minus 320. Okay. So once I'm right, keep it there. Alright, so we're left with. Alright, so let's see. Let me write it down so I'll kind of keep in mind where we're at. And then I can flip this board over a lot easier. So let's see if we can do this. Okay, so let's see. Excuse me for doing it this way. Let's see, limit as h approaches 0. So negative 32 ah minus 16 h squared over h. Okay. Alright, I know where I'm at on this. Now, negative 32 ah minus 16 h squared. Okay. Alright, I just have to convince myself that everything is good. Okay. Alright, so well, let's go back and erase this portion here. I don't need any of this. I don't need to erase a whole lot of it, but I would like to clear a board before writing anything else. Okay. Okay, so now we have the limit. We're at h approaches 0. Alright, now we had negative 32 ah minus 16 h squared over h. If you notice, we have a common h that we can factor out, so limit h approaches 0. We're getting close now. Oh, we could factor out a negative 16 if we wanted to, but we're just going to leave just factor out the h. Negative 32a, let's see, minus 16h. Okay, over h. Now as h approaches 0, we can simply plug that in. Limit as h approaches 0, negative 32a minus 16 times 0. Okay, that's where we're at. And so the instantaneous velocity right, is equal to, well, v, which is negative 32a. That's it. All right. That's it. Yeah. That's all it is. Now that we know what the instantaneous velocity is, then we can say, we might just go ahead and do this now. At t equals 2, at t is equal to 2, then we can simply do this. V is equal to negative 32 times 2, which is equal to negative 64 feet per second. And maybe we could have done this from the start. The reason why it's negative, well, why do you think that is? If we look again at our problem, the sandbag is dropped from a balloon 320 feet above the ground. So that is going to be a negative number because the direction is going down. You throw something up, the velocity is positive. When it starts to come down, the velocity is negative. Okay, so that is what we're doing here. Alright, so that's, once you get that general equation, you can just plug it in. T is equal to A, which is 2 in this case. We might just say even in terms of T. So anyway, just plug that in just like that. And so that's basically what we're doing here, is once we figure out the general velocity equation at some A, which is really in terms of T, T which is A which is T, which is 2 seconds. Okay, and then you just simply plug in the 2 in place of A. Alright, there it is. And I could do one more thing about this, but the time is short, so I'm just going to go ahead and leave it at that. This is pretty good here. So just keep in mind the two things that we talked about, is that the average velocity is going to be given by, it's s at A plus h minus s at A. Oops. Okay, if you want to say t, you can probably, all over h. And remember, it's on some kind of interval in this case, so it doesn't matter. Maybe we can say, in this case we had 2, 2.5. Okay. So anyway, so in general we could even say, maybe C, C plus A, or something like that. Okay, or A plus C. Alright, whatever. And that A plus C is actually going to be 0.5, whatever, plus that. So, alright, so that's the general idea there. Okay. That's the average velocity. The instantaneous velocity is the limit of the average velocity. Okay, which is the limit of this, like we just did a while ago. Okay, so just kind of keep in mind the difference between the two. I was telling my wife that average velocity could be like I drive a few miles down the road. Let's say a few miles down the road, I drive 50 miles an hour, and then at times I drive 60 miles an hour, and then at times I drive 70 miles an hour, and then you would just take those three and you would add them up and divide by 3. In this particular case here, instantaneous velocity would be at, let's say, maybe after so many seconds or so, this is when the policeman is pointing the gun at you, the instant that you cross his radar gun. That is instantaneous velocity. So if you're supposed to be going 70 and you're going 80, he can catch you. That's why he goes after you. If you're staying at or below that, then of course he's not going to pull his car out after you and run after you, or he shouldn't do it anyway. So anyway, that's instantaneous. Okay, so average, you add them up and divide, or whatever. All right, so this is the formula right here. Average velocity, and then the limit of the average velocity is your instantaneous velocity. I hope that's been helpful to you. I certainly want to do the right thing and teach it correctly, and I believe I have done that to this point. But if you see something that I have done incorrectly, feel free to say, hey, KP the Math G, you needed to do this or that. I'll be more than happy to look at your comments and say, oh, okay, and I will correct it if I do something incorrectly. But anyway, I appreciate everyone, and hopefully you will have a really good grip. You're starting to get a good grip on this average and instantaneous velocity. I think later on what I'm going to eventually get into the derivative, but I do want to look back at something that I skipped over, and I might want to discuss that. And I may take a little time to discuss that. It's called the intermediate value theorem, and I want to look a little bit at that. Okay, and so anyway, there's the intermediate value theorem. There is the mean value theorem, and then there's the extrema value theorem. So 3 of those, but we're just going to look at the intermediate, and there's a rule for that. Okay, and we'll just take one at a time. All right, well, that's pretty much it. I'll see what direction I want to go with this in another thing. And please, if you have any, if you see that subscribe button, please press that. And I may even start a tutoring service very soon. I don't know, but especially in the Hot Springs area, or even further out than that if you need some help. Okay, so I'm just here to help you, and if you have a certain topic, it doesn't have to be calculus, but if you have something that's even Algebra 1, Algebra 2 related like that, pre-calculus or trigonometry related, I will be more than happy to answer to the best of my ability your question. All right, thank you so much, and I appreciate you for your time.